Example 2 of the washer method. In this example we have two functions, y equals square root x, y equal x squared, that we want to revolve about the x-axis. Here's our generic formula. As I begin this problem, I probably should graph it so I understand what I'm looking at. I know that the square root of x looks something like this, and I know that a y equal x squared is just a parabola that's shooting upward like this, which means it's going to have this little slither right here that's bounded by those two curves. If I'm revolving it about the x-axis, it'll create a mirror image down here, and this would be a three-dimensional object. Notice that it has this void where that red line is. This would be basically a bullet where that tornado shape is being extracted from it. So there's a void inside my solid of revolution, which is telling me I want to use that washer method. So I'll just put this together now. I need to find where these two things intersect. I happen to know this, that the square root of 1 is 1 and 1 squared is 1. So this must be at x equal 1 and this is x equals 0. So I have my boundaries. I can say my volume will equal the integral from 0 to 1 pi. Now my first radius is my big radius. It's the furthest distance you travel from your axis of revolution out. And that would be your rad x there. So rad x that gets squared, I'll go ahead and write this just so you're following, minus pi. The least distance that I travel from my axis of revolution is actually the x squared part. And since that's going to be here, I'll say x squared squared, and then I have a big old dx on the end. Now before I go to my calculator to cheat, I'm going to simplify this a little bit. This will be pi x, because square root of x squared is just x, minus pi. X squared squared is x to the fourth dx. Now I can go to my calculator and I'll simply type what I have there. I'll do my pi button, x, remember pi is just a number, minus pi x to the fourth my calc option tells me go down to option 7 to integrate, and I'm going to integrate this from 0 to 1. And as I say in almost every video, understand that here's the picture of the area, but I'm finding volume, so this is going to look different than my picture for my graph of the area. And so then I'm going to go from 0 to 1, and it gives me 0.942. That's 3 decimal places rounded appropriately. 0.942 units cubed. Now we're going to start to get a little bit more advanced in the next couple of examples. What I'm going to keep working with is this distance from our axis of revolution. The big R is your furthest distance out. The little r is your least distance out. And that's what I'm using on these here. I'm looking at this formula. Big R is your furthest distance out. Little r is your least distance out from your axis of revolution. This was example 2 of the washer method.